So in the last video, we talked about R and S stereochemistry when it comes to a single chiral carbon, a single stereogenic center. But as it turns out, alkenes can also have stereochemistry. So if we remember, an alkene is just two carbon atoms with a double bond between them. So this is an alkene, and because carbons each have 4 bonds and they each have 2 little appendages coming out from them. And so instead of R and S, we use E and Z for alkenes. And as you can see here, E stands for Entgegen, which is actually just the German word for opposite. It's German for opposite. And then Z is the German word for zusammen, and as you might have guessed, it's the German word for same. And what this means is, so if we sort of divide this double bond sort of right down the middle, hamburger style, what we mean by opposite is essentially the 2 highest priority groups are on opposite sides of this sort of equatorial divide. And Z means that the 2 highest priority bonds will be on the same side of the equatorial divide. So if we use an example of E, say we have a fluorine right here, we'll call this a hydrogen, we'll put the hydrogen here, and we'll put maybe like an ethyl group right here, because ethyl, we have a C there. So we can see that if we just look at this side, we can see that obviously fluorine is the highest priority group because it has the highest atomic number. And then if we look on only this side, we can see this ethyl group has a higher priority than hydrogen. So that's the highest priority group. And we can see that, sure enough, the 2 highest priority groups are on opposite sides. And so if it was the same, if this was a Z stereoisomer, then it would just be like this. The 2 highest priority groups on each side will be on the same sort of divide on the equatorial hemisphere. And so if we, here's a little bit more complicated example. If we take, let's see, if we reproduce one right here, we'll give this a ethyl, we'll make this kind of like a propyl, and then we'll make this a methyl, and we'll make this a methyl. And so if we use the skills that we just developed, we take a look at this side. So we see this is an ethyl, so we have a carbon there and a carbon there. This is a propyl, so we have a carbon there, and a carbon there. You might be thinking, well, these are all carbon atoms, they're both the same atomic number. How do we decide which one is higher priority? So you basically just you keep going out until you can't go out any further. And so if we go out 1, we see that both are carbon atoms. We go out to the next one, we see both are carbon atoms. We go out to the next one, and theoretically this would just be, these are just hydrogens sticking off right here. And so if we go here, then we go out to the next one. So we'd go out to a hydrogen here, we go out to a carbon here. We see that the carbon is obviously a higher atomic number than the hydrogen, and so this propyl group is a higher priority than the ethyl group. And if we look over here, we see that these are both methyl groups. And so which one is higher priority? Well, it's actually a trick question. They're both the same priority, and so we can't select one as a higher priority. And so this molecule right here actually does not have stereochemistry, and so we would not use an E or a Z designation to identify this molecule as. So this one has no stereochemistry. But this one would have E stereochemistry, and this one would have Z stereochemistry.